All right, so we're going to talk about radian measure. Now, what I have pictured for you guys here is the unit circle. And in this case, I only have the radian angles associated onto it. You guys are probably pretty familiar with this with degrees from last year. But just to kind of throw the degrees in for that first quadrant, we have our 30-degree angles, our 45-degree angles, and then also our 60-degree angles. Now, these are, you guys did a lot of trig with them last year, and we're going to review and practice a lot of that here during this week. Now, what I do want you guys to understand is we are going to be using mainly radians throughout the year. So even though you might be really comfortable finding sine, cosine, tangent with 30-degree angles, really when we are gearing up towards calculus, we need to be working with radian measures. So I need to try and get you guys comfortable with thinking about pi over 6, pi over 4, and pi over 3. Now, one thing with that is you're going to have to start to understand what's in each quadrant. So which pi over 6 falls in quadrant 1, 2, 3, or 4. And same thing with the pi over 4s and pi over 3s. But one little trick I'd like to show you guys is focus in on our different angles here. So we have pi over 6, and in each quadrant there's only one pi over 6 angle. Right, so you have 1 pi over 6, 5 pi over 6, and 11 pi over 6. Now we have the same thing with our pi over 4s, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And then finally with our pi over 3s, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now I have a little trick that I had used last year in my classes, felt pretty good about in terms of writing them and being able to identify which one falls in which quadrant. And I'm going to start you guys actually with the pi over 3s because it's the easiest one to start with. So what I'm going to do is just have this axis here and focus in on pi over 3. Now, we always start with just 1, right? 1 pi over 3. You don't have to write the 1 in if you don't want. I'm just trying to kind of prove a point here. And then we're just going to count. And as I count forward, I'm going to do 1 pi over 3, 2 pi over 3, 3 pi over 3. I'm only going to write the number down if it doesn't reduce. So I'm going to start with 1 pi over 3 and then count up. So now I have 2 pi over 3. And since 2 over 3 doesn't reduce, I'm going to write that in the next quadrant. Then I count to 3 pi over 3. Since 3 over 3 reduces, I'm not going to write it down and keep going. Then I have 4 pi over 3. And then finally 5 pi over 3. And I've filled in all of my quadrants. Now this is going to be the same thing with my pi over 4 angles. I'm going to start by writing in 1 pi over 4, 1 pi over 4 here, and count up. So then I have 2 pi over 4, which reduces. Then I have 3 pi over 4, and as I keep counting, I'd have 5 pi over 4, and 7 pi over 4. Now, I would say if you guys are starting to think you feel comfortable being able to count that around, try it with this next one on your own. Give it a quick pause, and then check it after it's all done, see if it worked. But then you have 1 pi over 6, then we count 2 reduces, 3 reduces, 4 reduces, and then finally we'd end up with 5 pi over 6 in the second quadrant, 6 reduces, 7 pi over 6 does not, 8, 9, 10 all reduce, and then we'd end up with 11 pi over 6 to fill out that table. So this is going to become really useful and helpful over the course of the week, but just look for that pattern, try and understand how to create this chart, and you guys should be good with that for today. Now I do also want to talk to you guys about conversions with degrees and radians. So last year you guys also worked on converting, and same thing in geometry with converting a certain number of degrees into a radian measure. So let's just review it and then get you guys a little practice with it today. So when we're converting from degrees to radians, you guys are going to have to multiply by the conversion factor of pi over 180. Now typically we'll leave the pi in the answer. So for instance, this first example, 140 degrees, we're going to multiply by pi over 180. And the nice thing with this is you're going to end up reducing. So you're going to have 140 pi over 180. We end up with a nice, I'll kind of show you guys here a bit. The zeros cancel, And then the 14 and the 18. The 14 can reduce by 2 to get 7, the 18, 9. So we get a final answer of 7 pi over 9 radians. All right, so try the next thing with number 2. If you want, hit pause, and then you'll get the answer. All right, so with number 2, we want to do the same thing, multiply by pi over 180. And after we end up reducing, we end up with negative pi over 4. All right, let's check out this next thing now. So going the opposite way, to convert from radians to degrees, we're actually going to multiply by the reciprocal. So we're going to multiply by 180 over pi. I cancel out those radians. So to take a look at this first example, you guys are going to multiply by 180 over pi. And the nice thing is here, those pi's are going to cancel. And then you're going to have 2 times 180 to get 360 over 5 times 1 to get 5, which then reduces down to 72 degrees. All right, try the next one. You guys can hit pause, and then you can check your answer with me once you're all set. All right, so welcome back. If you guys take a look, with this one, we want to do that same thing. We want to multiply by 180 over pi. We could cancel out those pi's. And after all has been reduced, you guys should end up with 80 degrees.